Welcome to this episode of Miss Prince Physical Science Connection. Today's topic, the periodic table. You know, we are always organizing things, whether it's the dishes in the cabinet, the color pencils in your school box, or even the clothes in your closet. It's always something. So why don't you think of one thing in your life that you like to keep organized? How did you organize that thing? Why did you organize it in that manner?
All right, so you know that you have things that you like to keep organized. You know that other people around you have things that they like to keep organized. And guess what? Scientists are the same way. They like to organize information too. And in the 1800s, the scientists looked at the elements and said, these elements, we can organize them in some type of pattern. So let's see if we can do this. And so they take the elements and they're looking and they're pulling the characteristics of each element. They get this information and put it together. And what we have is in 1860, Dmitri Mendeleev, he takes that information and he makes himself some element cards and he sorts them on the table, and he realizes that how he sorts them is according to their mass. He arranges them by the mass number, and that's typically the number that you find at the bottom of your element square along the periodic table. And by 1869, he is able to produce the first periodic table. Now, this wasn't a perfect periodic table. It had a lot of gaps because there were still many elements that had not been discovered by that time, but he had just enough to find a pattern. And that's where we come up with this word periodic, because the word periodic means that there is a repeating pattern. So we see that, as we move from left to right, the mass is increasing. And he made some other predictions. He was able to predict where certain elements could probably fall, what certain elements could possibly be named. And we'll look at those in the next couple of slides. But it wasn't until 1913 that the periodic table went from being arranged by the atomic mass to the atomic number. Once the periodic table is changed to an atomic number, then we're going to see a shift in where some of the elements are arranged.
Okay, so here's a view of all the elements known at the time when Mendeleev took his periodic table of elements and sorted them on a table. Now, what you see is that we have many that kind of go one after the other, and then you'll see that maybe there are one or two spaces that are empty. Those empty spaces, like here, here, and here, that just means that those elements weren't discovered at that time. But then we have some other elements, like this one, and this one, this one, and this one, that Mendeleev proposed based on some of the information about the elements before them or after them, that would be the specific element that would go there. Now, of course, when he shared his ideas with other scientists, they were a bit skeptical about his position on the periodic table. However, within about a 20-year period since the setup of the first periodic table, scientists discovered 3 more elements, and they discovered the elements according to what Mendeleev proposed. Now remember, since then, the periodic table is no longer organized by mass. It's organized by atomic number. Once the periodic table was organized by atomic number, some of the elements had to shift around in their placement just a bit. Over the next few slides of this presentation, we'll talk about the organization of the current periodic table. First, let's talk about the general structure of the periodic table. And the first 2 things that come to mind are groups and periods. We'll start with the groups first. Groups are the columns, and they all go up and down. We have 18, from 1 to 18, total groups. Okay? And elements in those groups tend to share similar properties. Then we have periods, and the periods run horizontally from left to right. And we have 7 of those periods. Elements in the same period or same row have the same number of energy levels, but whereas they have the same properties in groups, they have different properties in periods. As I stated earlier, the elements along the periodic table are arranged by atomic number, so from 1 to 118. And they're also arranged by properties. Elements from left to right range in different levels of reactivity. On the left-hand side, your elements over here are more reactive or highly reactive in comparison to the elements on this side, which have low reactivity, or in the case of the final column, no reactivity. Elements are also arranged into 3 regions. We have the metals, we have the nonmetals, and then we have a small zigzag section of metalloids.
So I'm probably thinking that you're thinking that outside of the information on the element squares and knowing that the periodic table is arranged by atomic number is probably all the information that there is about the periodic table. But unfortunately, there is just so much more information that we can pull from the periodic table. While we don't have enough time to go over all those other things, and I'm sure your chemistry teachers in high school don't want me to give away all the surprises, we'll just talk about a few more basic items. Now, we know that there are 18 groups. And when we get ready to talk about reactivity and bonds at a very basic level, there are some things that I want you guys to remember. So when we're looking at each column, the column gives us an idea about the number of valence electrons. So if you look at each column there, with column 1 or group 1, we know that those elements have 1 valence electron. In column 2, we know that those elements have 2 valence electrons. But then we jump way over, skip the transition metals, get over there to group 13 through group 18, and then we find that those elements have 3, 4, 5, 6, 7, and 8 valence electrons. Now we'll talk about that special number 8 in a different presentation, but let's go back and look now at some other characteristics. When we look at the elements on the left-hand side of the periodic table, those elements like to form positive bonds, positive ions. So in order to form positive ions, they've got to get rid of some of that negativity. So in order to get rid of some of that negativity, they are going to give away some electrons, okay? And depending on what group they're in will determine the number of electrons that are given away. However, if you go way over to the right, the further to the right you go, then you're going to find that your elements on that side are going to want to take electrons. So they form negative ions because they are increasing their negativity. Okay, so on the left we've got positive ions, on the right we have negative ions. And then we have that wonderful group 18. And group 18, that's a pretty stiff bunch of elements. They don't really care to bond with others, so we don't normally have any ion formations at all with group 18. But again, we'll talk about that in a different presentation. I'm sure you're probably wondering why on earth the lanthanides and the actinides are not where you probably would think they should be along the periodic table. And if we, let's say, decided to put them back in the periodic table, in extended format, this is what you would get. Not so friendly of a periodic table. It kind of stretches out your groups for going from 1 to 2, then you have this huge space, and then you pick up a 3, 4, 5, all the way over to 18. So it's a bit confusing. So it's easier to look at the periodic table in the normal format in comparison to the extended format.
The first region of elements are the metals, highlighted in yellow. Most of the elements in the periodic table are considered metals. Metals are good for conducting electricity and heat. They're shiny, they shape easily, and they're all solids with the exception of mercury.
Region 2 consists of the metalloids, and elements in the metalloid section fall along the zigzag line. And these elements have properties of both metals and nonmetals, and they're mostly used for semiconductors.
And the final region is region 3, your nonmetals. Here and then hydrogen way over here. These are going to have the opposite characteristics of metals, whereas you have metals that are shiny, your nonmetals are solids that are dull and they can't be shaped. They're poor conductors of heat and electricity, and they consist of liquids and gases in addition to the solids.